Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here, and today I'm gonna talk about price between coupon dates and callable bonds. So up to now we have determined the price of a bond on a date that is exactly one period before the next coupon date. In this section, we will consider the price on a date that is a fraction k of a coupon period after the last coupon date. And there are two main types of bond price between coupon due dates problems. The first type is when the price is actually paid on the date of purchase. And the second type is the price that is coded for the bond in the financial press. The practice of the second type is to quote the price including the value of the coupon that has accrued by the date of purchase. So let's take a look at the first type, price actually paid on the date of purchase. Assume that the last coupon was paid at time t, measured in coupon periods, and the bond will be sold at time t plus k, where k is a fraction of a coupon period in time t. Here k is between 0 and 1. K can be either 1/2, 1/3, 2/3, 4/5, any fraction between 0 and 1. We will use the symbol BT for the price of a bond after the last coupon was paid, and BT plus K for the actual price at time t plus k. So to find the bond price at time t plus k, we can accumulate the bond price at time t to time t plus k by simply multiplying 1 plus I to the k. Or we can look at the bond price at the next coupon date and times with v to the 1 minus k. Example 1. Consider a bond. The bond price at time 0 is 1074.04. The bond price at time 1 is 1066.26. The bond price at time 2 is 1058.25. The bond price at time 3 is 1050. Interest is 3%. The coupon is $40 per each period. Then the bond price at time 0.25 is calculated by the bond price at time 0 times 1 plus I to the k, which is 0.25. So the bond price at time 0.25 is 1082.01. Or we can look at the bond price at after the first coupon date. So the bond price at time 0.25 is the bond price at time 1 plus 40 times v to the 0.75, and we got 1082.01, the same answer. Here in this example, you see that the coupon was either multiply with 1 plus I to the 0.25 or multiply v to the 0.75. So in the first method, the coupon is calculated using the interest. In the second type question, the coupon will be calculated using the accrued interest. So now we look at the second type, price coded in the financial press. In this method, the bond price coded in the financial press is equal to the actual bond price minus the accrued coupon, because the bond is sold between coupon days. So we're just going to have only a portion of the coupon. So assuming that the accrued interest is 0 at time t and 1 at time t plus 1, by simple approximation, the accrued coupon at time k is k times FR. FR here is the coupon. So in the second method, the price quoted in financial press, the coupon is not the whole coupon, but it's just a fraction, a portion of the coupon. So the price quoted in the financial press is BT plus K minus K times coupon. Or you have BT times 1 plus I to the K minus K times FR. So that means in the second type, price quoted in the financial press, the coupon also should be approximated, not using the whole coupon. Example, consider a bond B0 as the bond price at time 0. So the bond price times 0 here is given at 1074.04. At time 1, the bond price is 1066.26. At time 2 at 1058.25. At time 3 at 1050. And interest is 3%. The coupon is $40 per each period. So the bond price at time 0.25 is 1074.04 times 1.03 to the 0.25 minus 0.25 times 40 using these formulas. And the bond price is 1072.01. Compared to the price actually paid on the coupon dates, you see that there is a difference of $10. So when you have the financial price, the bond is 1072.01. Using the last methods, we got 1082.01. So we've been working with K, but for the last few problems, K was given. However, on the exam, sometimes you have to calculate K because K is not given. Here, I'm going to introduce two methods to determine the fraction K. Let's consider this example. Suppose a semi-annual coupon bond pays coupons every July 23rd and January 23rd. That means semi-annually, twice a year. Say the bond will be purchased on November 3rd. Determine the fraction K. So here by the actual methods, for the fraction we have the numerator and the denominator. For the numerator, we have to calculate from the last coupon date to the day November 3rd. And for the denominator, we calculate the number of days on the whole coupon period. So the numerator here is 8 plus 31 plus 30 plus 31 plus 3, because in July, from July 23rd to July 31st, we have 8 days. From July 31st to August 31st, we have 31 days. From August to September 30th, we have 30 days, and so on until November 3rd. At the denominator, we calculate the number of days between July 23rd and January 23rd. Here we have to look at the month to determine how many days a month has. So K is 103 over 184. But for convenience, sometimes we assume that a month has 30 days, no matter it's February or January or August or September. So that method is called 360 method. That means we assume a year has 360 days and 30 days a month. So here the numerator, in July we have 8 days left. In August we have 30 days, September 30 days, October 30 days, and November 3 days. And the denominator is just the number of days between the coupon days. And here the circle is half year, so 180 is the denominator, which is 1/2 of 360. So by the 360 method, K is 100 over 180. Usually on the exam, I suggest you to go by the actual method. The 360 methods works fine, but usually it gives you not precise answer. So just use 360 method in case the question indicates that you should apply 30-360 method. Callable bonds. A corporation or government entity that borrows money by issuing bonds might also want to take advantage of a decline in interest rates after the bonds are issued. For this reason, many bonds have an option that permits the borrower to call the bonds to redeem them prior to the normal maturity days. For example, if you buy a bond and the bond matures in 20 years, a callable bond is the bond that allows you to call the redemption value anytime before, sometime before the actual maturity day. So these callable bonds generally have an earliest call date that is several years after issue. For example, a $100 bond with 6% annual coupons and a maturity date 20 years from now can be called or redeemed by the issuer at par on any coupon date starting 10 years from now. So that means even though the maturity date is 20 years from now, but after 10 years you can call the bond anytime. So what is the highest price the investor can pay to yield at least 4% effective? So for this question is basically asking depending on whether the bond was sold at premium or discount. Just let's think about premium. For premium bond, you invest, let's say $100. The redemption value should be less than the price because it's premium. Remember from the last lesson, if P is greater than C is premium, otherwise discount. So for premium bond, suppose you invested $100 today and the redeemable value is 92. That means there is an $8 loss. So this $8 loss will be spread over the bond life. So the longer the bond, the less pressure you have. So for premium, bond, the earlier time should be the worst. That means the earlier time will give you the most expensive bond. For the discount is opposite. Suppose you invest $100 today, the redeemable value should be greater than the money you invest today. So let's say 120 is the redeemable value. So that means there is a $20 that you actually earn. So you don't expect this $20 to be spread too wide. So the latest redeemable day should be the worst. That's why here we have a conclusion. For premium, the earliest is the worst, and for discount, the latest is the worst. So to answer question in example 4, we basically determine first whether this bond is sold at premium or discount. So if at premium, the earliest is the worst, that means the highest price is at the earlier time, and the lowest price should be the later time. For discount, for a discount bond is opposites. The highest price is the latest redeemable day, and the smallest price is at the earliest. So here, because you can see that here the coupon rate is 6%. This is R. And remember here, because the bond is redeemed at bar, that means G is also 6%. And we expect the interest to be 4%. That means G is greater than I. So this is a premium bond. And for premium bond, the earliest is the worst. That means the earliest is the most expensive. So to find the highest price, the investor can pay to you at least 4% effective. We basically find the price if the bond is called at the earliest time, which is 10 years from now. So the price of the highest price is 618 plus 100 b to the 10 at 4%, which is $116.22. Now suppose at the beginning you pay $116.22 for this bond, but then you call the bond at time 20, then the yield interest rate should be 4.73%, which is higher than 4%. You see that? So that is everything for bond. Now we are going to practice some problems. First question, Toby purchased a 20 years par value bond with semi-annual coupons at a nominal annual rate of 8% convertible semi-annually at a price of $1,722.25. The bond can be called at par value $1,100 on any coupon date starting at the end of year 15. What is the minimum yield that Toby could receive and expressed as a nominal annual rate of interest? Convertible semi-annually. So for this question, you have two approaches. Either you can try from year 15 to year 20 to see which year will give you the minimum yield rate. Or you can figure out if this is a premium or discount. So let's look at the first method. Let's say N is the year that you should call the bond. So 1722.25 is 44 A to N I over 2 because here the bond is redeemed twice a year and interest also convertible semi-annually. So let's say I is the nominal interest rate. So for each half year we have interest I over 2. And we are going to try N from 15 to 20, and we figure out that at year 15 the yield interest is the minimum, which is 1.6% for I over 2 and I is 3.2%. Another way to look at this is you can see that the price here is greater than the redeemable value. 1100 is less than the price. So that means this is a premium. For premium, the earliest is the worst, and usually we expect to have high yield rate. But here the minimum, the question asks for the minimum. That means the question asks for the worst. So the bond should be called at the earlier time, which is at time 15. So we basically just use 15 as the year to compute the interest rate, and we got 1.6% for each half year, 3.2% for the whole year. Problem 2. Rebecca purchased a 100 par value bond with 5.7 semi-annual coupons maturing in 15 years and redeemable at $92. The bond can be called on the 11th through 26th coupon day. Find the maximum price Rebecca should pay if she is wishing to make a minimum yield of 6% convertible semi-annually. So for this question, whenever you read a question, find the maximum price to have the minimum yield rate, or find the minimum yield rate to have the maximum price, you think about either whether this bond was sold at premium or discount. So to determine if this bond is sold at premium or discount, we need to calculate G, the spectral coupon rate. So G is FR over C. And R here is 5.7% divided by 2 because this is semi-annual coupons. So we got G is 0.031, which is greater than 0.03. This is I. Because 6% convertible semi-annually, so it's half year, we got 3%. So here G is greater than I, which means this is a premium bond. So for premium bond, the earliest is the worst. We mean the earlier time you buy the bond, the more price you have to pay. So the maximum price should be at time after 11 coupon. So the maximum price is 2.85 A11 plus 92 V211 at 3%. Because here is half year, you have 2.85% of 100 bar value for coupon. 92 is the redeemable value, and after 11 coupon, N is 11. Interest using here 3%. So the maximum price Rebecca should pay if she's wishing to have minimum yield rate of 6% convertible semi-annually is 92.83. Question number 3. Which of the following statement is not true about the highest price an investor in callable bonds can pay and still be certain of making a specific minimum yield rate? A. It should base on the worst possible redemption date to the investor. This is true because when we consider when the bond should be called to have either maximum or minimum yield rate, we think about whether it's a premium or discount bond to figure out the worst possible redemption date and the best possible redemption date. So A is correct. B, they determine as the lowest price for all the possible redemption date. This is not correct because the lower price sometimes does not guarantee a minimum yield rate, a minimum specified yield rate. C, when sold at a premium, early redemption date is worth to the investor. Yes, this is the rule. For premium bond, the earliest is the worst. And for discount, the latest is the worst. So C and D are both correct. E, the earliest redemption date should be assumed. We cannot assume that, so E is not correct. Question 4. Mason purchased a $1,000 par value 12-year bond with annual coupons of 5.7% at a price of 263.52. Find the yield rate of his investment given the present value of the redemption value is 731.66. So here in this question, the redemption value is not given, but they give us the present value of the redemption value. So the price is 263.52. This is equal to the coupon times AN plus CV to the N. The coupon is 1,000 times with 5.7%, which is 57 for the coupon. And here the bond lasts 12 years, so N is 12. And instead of using C times V to the N, we're not given C, but we're given K. K is 731.66. So this K is exactly C V to the N. So there's no V to the N here, just 731.66. Now simplify the equation. We have 531.86 a 57A12. Using this equation, we got the interest rate, the yield rate is 4.10%. Number 5, a 1,000 par value 10-year bond with coupons at 5% convertible semi-annually is selling for 1,081.78. Calculate the yield rate convertible semi-annually. So this question, they give us the par value F, the price P, N is 10, R is 5%, convertible semi-annually, so 2.5% for each half year. And the question asks for I over 2. Let's say I is the yield rate, the nominal yield rate, then the interest for for its half year is I/2. So the price 1081.75 is equal to the coupon $25 A20, because for 10 years and time 2 is 20, because each year is convertible semi-annually. And interest here we use I/2 because I is the interest rate we are looking for. And 1,000 is redeemable value, because here is set par value. So if the question gives you a par value bond, that means it's in the case the redemption value is at par. So using this equation, we figure I/2 by calculator and then times 2 to get I. So I is 4%. So that means the nominal interest rate is 4% convertible semi-annually. Question 6, a 10,000 par value bond with coupons at 8% convertible semi-annually is being sold 3 years and 4 months before the bond matures. The purchase will yield 6% convertible semi-annually to the buyer. The price at the most recent coupon immediately after the coupon payment was $5,640. Calculate the market quoted price of the bond. So for this question, pay attention to the bond is being sold 3 years and 4 months before the bond matures. And this bond is convertible semi-annually, so 6 months is the coupon periods, and this is 4 months, 3 years and 4 months before the bond matures, so we use 4 months to calculate K. 4 months before the bond matures, that means 2 months after the last coupon date. So K here is 2/6, which is 1/3. So the price, the quoted price is the actual price, the actual bond price, minus K times with the coupon. Here the last bond price was $5,640, then time with 1 plus I to the K. K here 2/6. Interest is 3% because 6% convertible semi-annually, minus K time with coupon. Coupon here 8% convertible semi-annually. That means it's half year we got 4% of 10,000, which is 400. So using this equation, we have the quoted price for this bond is $5,562.51. Problem number 7. 1,000 par value in year bond with 100 annual coupons is purchased for $1,110. The bond yields the effective annual rate of interest I to the purchaser. You are given V to the N is 0.45 YCI. So for this one, we are given the price. 100 is the coupon. Let's say N is the length of the bond, the life of the bond. 1,000 is the redeemable value. So 1,110 is equal to 100 AN plus 1,000 V to the N, and derive A to the N, AN. AN is 1 minus V to the N over I. And then combine them together, we have 100 minus 100 V to the N over I. The first two term over I is 100 AN. And 1,000 I VN over I is just 1,000 V to the N. And here we are going to replace 0.45 for V to the N. So we got 100 minus 45 plus 450 I over I. And this equal to 1,110. Solve this equation for I. We got I is 8.33%. So that is everything for today. Thank you so much for watching my video. I hope you guys enjoyed my video, and I hope it's helpful for you to practice on exam FM. Thank you and see you next time. Bye.